We have now computed value at risk estimates, but computing VaR is only the first step. The next question is whether the model behaves as intended when we compare it to realized returns. This is the purpose of VaR backtesting. VaR backtesting is conceptually simple. Once we fix a VaR threshold, we look at realized daily returns and just count how often actual losses exceed that threshold. Each time the realized return falls below the VaR level, we record what is called an exception. Let's walk through the backtesting table column by column. This table summarizes how a historical 95% VaR model performs over the full sample. The first column identifies the VaR model being tested. In this case, we are testing a historical 95% VaR with a constant threshold, meaning the VaR level is fixed over time rather than re-estimated dynamically. The next column shows the VaR threshold expressed in return space. Here, the threshold is approximately minus 1.65%. This means that any daily return worse than minus 1.65% counts as a VaR breach for this model. Probably the most important columns are the exception rate and the expected rate. The expected rate for a 95% VaR is 5%, which is simply 1 minus the confidence level. The exception rate shows how often the VaR threshold was actually breached in the data. In this case, the observed exception rate is approximately 5.02%, which is extremely close to the expected 5%. This tells us that in terms of frequency, the VaR model behaves largely as intended. The next two columns provide the raw counts behind those rates. Out of 4,021 total observations, we observed 202 exceptions, meaning days where realized losses exceeded the VaR threshold. These counts are important because they show that the exception rate is not driven by a very small sample, it reflects a substantial number of observations. This backtesting result tells us that the VaR threshold is breached at approximately the expected frequency. However, this does not mean that the model is perfect or complete. VaR backtesting focuses on how often losses exceed the threshold, not how large those losses are or when they occur. A model can pass a basic frequency backtest while still severely underestimating extreme tail losses. In practice, VaR backtesting is used as a monitoring tool, not as a guarantee of safety. Persistent deviations between observed and expected exception rates can signal model breakdowns or even regime changes. This is why VaR is always complemented with tail risk measures and stress testing. Having validated the basic frequency behavior of our VaR model, we will now move beyond threshold-based risk measures. In the next section, we'll explicitly analyze tail risk, focusing on what happens when losses extend far beyond the VaR cutoff.